Hello and welcome to a lesson of physics. I hope you're doing well. So today we are starting off with the section of waves. So this is where we start from the A level content, intensity of waves. So this is the starting point of the wave for our syllabus of A levels. They do ask the question from the previous ones. For example, they can ask you to find frequency, they can ask you to find time period. We'll practice those questions as well, but I'm not going to go through the definitions and all that. So let us define the intensity of a wave. So intensity, first of all, is a physical quantity for a wave which is represented by the symbol capital I. And we define intensity as the energy delivered per unit area per unit time. Now, in simple words, you can think about intensity of a wave as how fast the energy is transferred by the wave over a certain area. So, if the wave transfers more energy per unit time over a certain area, then that means it has more intensity. The intensity is higher. Now, the same thing, the same description can be mathematically written as I, which is the symbol for the intensity, equals to E, which is the energy, per unit area means area in the denominator, per unit time means time also in the denominator. So both area and the time would be in the denominator with respect to the energy. So the formula is exactly the same as the description. So if you just memorize the formula, you can write down the definition as well. Then we also know another thing, that power equals to energy over time, because we study this thing as power equals to rate of doing work done over time. But we know work and energy, they have same dimensions, they have same units. The energy can be converted into work, and work done on an object can be stored in the form of energy. So these two are the same things. So what we can say is, instead of E over T, we can also write power. So instead of this thing can be collectively written as power. So I equals to the power of the wave divided by area. Okay, so this thing was collectively written as power. So that's the other formula. Now the question is, what units do we have for intensity of a wave? Well, we can see the unit of power is watts with the capital W, and the unit of area, the SI unit of area, is meter square. And if you shift it upwards, it would be per meter square. So watt per meter square. And they can ask you to convert it into base units in especially what we do in the chapter 1 of AS physics. They ask you to convert certain quantities into their base unit. So you have to insert the base unit of power. You have to break down watts into joules per second. Then joules needs to be broken down until or unless you have all the units from the table that contains 7 base units. But in A-level physics, we have only 5 of them. Intensity of light and the amount of substance are not included in the new syllabus. Okay, the next thing is different factors that would affect the intensity of a wave. Let's start off with the amplitude. So this one is very easy. For a wave that has higher amplitude, it would be having higher intensity. Because think about it. You have a sound wave and the amplitude of a sound wave is greater. Okay, for example, this is a sound wave with that much amplitude, and you have another sound wave with this much amplitude. The amplitude of a sound wave refers to loudness of the sound. We study that in O levels. So the louder the sound, it would be more intense because more energy can be transferred per unit time over a certain area. So for that simple reason, we can safely say the more the intensity, the more the amplitude, the more the intensity. But what is the exact relation between intensity and amplitude? Well, the exact relation is the intensity is proportional to square of the amplitude. It's not proportional to the amplitude, it's proportional to square of the amplitude, which means if you change the amplitude a little, the effect on the intensity would be significant. So they are not directly proportional. Intensity is directly proportional to square of the amplitude, not just to the amplitude. Now the same thing where A represents amplitude, the small a represents amplitude in this case. Now the thing is, if I want to convert it into an equation, I'll need to insert a constant. So let me insert a constant over here. I can write it as I equals to k times a square. What is k? K could be any constant. It would be a constant number because I needed to convert the proportionality into an equation. That's why I need to plug a constant. So let me rearrange it for the constant k. So k equals to I over a square. Now what do we make of this expression? That the constant k equals to I over a square. And like I said, k is a constant number. You would be having a fixed value. So that means the ratio of I and a square has to be same. The ratio is a constant. So we can write this thing as I1 over a1 square equals to I2 over a2 square equals to I3 over a3 square equals to I4 over a4 square. Matter of fact, at whatever point you take the ratio of intensity and the square of amplitude, their ratio would always be constant. So have we studied something like this already? Yes, we do. We have studied that in chapter of thermal physics, for instance, that volume is directly proportional to temperature. Then we say, okay, we can insert a constant and then k would be equal to v over t. And that's why we were able to write v1 over t1 equals to v2 over t2. So that's exactly the same thing. And I'm going to get rid of this thing. Now, what do we make of it? First of all, whenever they ask you a question in which the amplitude is being changed and amplitude and intensity of a certain condition is given, and now they change the amplitude and they ask you to find the new intensity, you'll be very safe if you use this formula as it is. And we will do that in the follow-up questions, in the sample questions. And the second thing, just a quick commentary on this one. So the question is, previously the amplitude was A, amplitude of a wave is A. It could be anything, could be 10 millimeter, 20 millimeter, 30 millimeter. We don't want to specify it. That's why I'm saying the amplitude of the wave is A. And at that point, the intensity is I. Okay, just so far so good, very easy terms. Amplitude is A, intensity is I. Now the next thing is, I changed the amplitude from A to 2A. What have I done? I have doubled the amplitude. So whatever the amplitude was there previously, it could have been 10 millimeter, but I have doubled the amplitude. The question is, if I double the amplitude, what happens to the intensity? right? Intensity would first of all increase, they are proportional to each other, and it would increase 4 times. That's absolutely right, because we have square of it. That's why the intensity would increase 4 times. So I think so far we're so good with it. Let's move on to the next factor that affects the intensity, and that is the distance from the source. What source? The source at which the wave is being produced. So the next one is distance from the source. For this one, the simplest explanation is if you're standing away from the wave, the intensity of wave at that point would not be significant. If you're standing very much close to the source of wave, the wave would be very intense at that point. So just think about it. You just dropped a pebble in the water, and then you have the water waves, and very close to the source at which the waves are being produced, the intensity of wave would be greater, and away from that source, the waves would not be that much intense. So what we can say is, as the distance increases, the intensity of wave would decrease. Now, what is the exact relation? The relation is this one. This is also related with square inverse. We call it inverse square relation. Now, this is a proportionality sign. I want to convert it into an equation so we can find the effect of it. So I equals to, there has to be a constant k times 1 over d square, but I can write it as k over d square. Then k constant would equal I times d square, and then you can write it as I1 d square times I2 d, something like this. So how can we be able to write it like this? Because the product of intensity and the square of distance, the product is constant. So at any point, if you multiply the intensity and the square of distance, the answer would be a fixed number. It won't change. So these are very important formula, like this one, and also the second one. And once again, they can ask you a question: if the distance is increased or the distance is doubled, then the intensity would be reduced by a factor of 4. So intensity would be I divided by 4, because you have to take square of it. And the last one is the relation between amplitude and distance. So if I combine these two, the first one and the second one, I can also write an expression that looks something like this. Now, how can we be able to write this one? So the first one expression was intensity is directly proportional to square of amplitude, and the second one was intensity is inversely proportional to the square of distance. Now if you combine these two, the left hand side the same. If you combine the right hand sides, it looks something like this. And if you take square root on both sides, it will be reduced to this thing. Sorry, we don't have square over here. It is amplitude is inversely proportional to displacement from source. So this is how we derive this one. If the distance is, for example, the distance is represented by r, then we can also write it as a inversely proportional to r. If the distance, for example, is represented by x, we can write it as something like this. But amplitude is inversely proportional to distance from the source. And likewise, this can also be written as, I'm not going to add the constant now and then rearrange it, but simply you can write it as a1 d1 equals a2 d2. If you follow the same steps for this one, you'll eventually be able to come up to this expression. First you add the constant, then you make constant the subject, and if the products are same, you can write a1 d1 equals to a2 d2 equals to a3 d3. Whatever point you consider, the product of amplitude and distance would always be constant. So let's move on to some of the sample questions that we have over here. And precisely, we'll try to solve the questions of intensity of wave. And all the simpler questions, I'll just skip forward those ones. So here we have the first one. How does the amplitude A of the vibrating air molecules vary with the distance r from the source? And intensity is given as I equals to P divided by 4 pi r square. So it is the same as the formula of intensity. Intensity equals to power over area. The second formula that we have written on the right side. And area in that case is 4 pi r square. But the question is, what is the relation between amplitude A and the distance r? Out of all the factors that we have studied, the intensity would be depending on this one. You have to figure out from those. A represents amplitude and D represents distance. So what is the relation between amplitude and distance? This is what we need to figure out. A. So A is the right answer. That's right. Amplitude and the distance from the source, they are inversely proportional to each other. Matter of fact, we studied that as a formula, as an expression. Okay, and they were expecting that you might be using the first expression, because you don't find the third one directly in the books. This one, you don't find this one in the books, in the recommended books. You find the first one, you find the second one, and they're trying to be sneaky here. They are under the impression that you might be working out with these two expressions, and eventually you'll come to the conclusion. But we studied this third one as a formula, as an expression itself. So let's take a look at the, and this one is very important. Let me number it as question 2. So the diagram shows the graph of displacement against time for a sound wave. So displacement time graph, what do you get from that? You can find the amplitude, and you can find the frequency, you can find the speed of, you can find the time period, but you cannot find the wavelength of the wave when you have time on the x-axis. If you have distance on the x-axis, then you can find wavelength. Or if they provide you with the speed of the wave, then you can find the wavelength by using the formula V equals to F lambda. And these are the formulas once again carried forward from O levels. V equals to F lambda, V equals to lambda over T, and F equals to 1 over T. And if you need to find the frequency, you can find frequency by cross multiplication as well. But anyway, this one question reads, intensity of the sound wave is reduced to half. It is half. Which graph shows the displacement of this sound wave? So whatever the intensity was previously, now the intensity is reduced to half of it. Whatever the intensity was previously, we don't know what was the intensity in this graph. We don't know. But what we know is that the new intensity is reduced to half of the original. So if you reduce the intensity, there would be an effect on the amplitude. We can all agree on that. If we change the intensity, and matter of fact, if we decrease the intensity, then the amplitude should also be reduced. Why? Because of this, intensity is proportional to amplitude. If you change one of it, then the other one would also change. And what would be the change? That's a different question. We can find the exact value of the amplitude, but what we know is the amplitude would decrease. So what is the amplitude? The original amplitude, we can say 1, 2, 3, 4. 4 blocks. Let's go with 4. The amplitude is 4. So we're not sure about the units, centimeters, millimeter. So 4 with arbitrary units. Could have been any units. Now in the option A, what is the amplitude after the intensity is half? 1, 2, 3, 4. It can't be same. can't be 4. Once again, B, same problem, same amplitude. It is not possible that you reduce the intensity and amplitude remains the same. That is not possible. Then for the option C, the amplitude is 2. Okay, the amplitude is 2. And for the option D, the amplitude is, what you see is slightly less than 3. Slightly less than 3. I hope you can see it clearly. The amplitude is slightly less than 3. So could have been 2.8, 2.9, or 2.85, could have been something like that. So amplitude slightly less than 3. So between 2.8 or to 2.9 something. Now the question is, if the intensity is halved, if the intensity is reduced to half, what would be the new amplitude? Let's make a guess first. So the thing is, you might be tempted to say the amplitude would also be reduced to half. That's not going to be the case because these two, intensity and amplitude, are not directly proportional. They're not directly proportional. That your intensity is reduced to half, then amplitude is also reduced to half. No, they're not directly proportional. They're related by a function of square. So what is the best way to answer this question? The best way is to write down the formula. To write down the formula that relates the intensity and the amplitude. And the formula is I1 over A1 square equals to I2 over A2 square. I1 is the previous intensity, A1 is the previous amplitude, I2 is the new intensity, and A2 is the new amplitude. So let's say the previous intensity was 1 and the previous amplitude was 4. It was 4. 1, 2, 3, 4 blocks, and then we have to take square because we have square in the formula. What is I2? It's the new intensity, and the intensity of sound wave is halved. So half of 1 would be 0.5 divided by A2 square as it is, because we need to find the value of the new amplitude. So you can take any value of intensity. For example, you could have taken the initial intensity as 2 and the new intensity would then be 1, because the new intensity has to be half of the previous one. Or it could have been 4 and then on the right side 2, could have been 8 over here, and then on the right side you can write 4. So let us cross multiply, and A2 square would be multiplied by 1, doesn't make any difference. So 4 square would be 16 times 0.5. 16 times 0.5 means 8. So A2 square equals to 8, and that thereby A2 equals to square root of 8, which is 2.8 something. So the new amplitude, after you reduce the intensity to half, the new amplitude is 2.8. What does that mean? Just pick up the option in which the amplitude is 2.8. So you see, now compare. In C, the amplitude is exactly 2. In the option D, the amplitude is 2 like I was saying, slightly less than 3. So it would be 2.8. So D is the answer for this one. So here we have P2 questions from this topic. And once again, I'll be confining myself to the questions of intensity, and the previous questions will just fast forward. So for a water wave in which all wavefronts are parallel to one another, the variation with time t of the displacement x of the particle in the wave is shown in figure 5.1. So this is the graph, which one? amplitude, sorry, displacement time graph for the water wave. Below that, you have displacement distance graph. So at a distance of 0, you're standing exactly at the source of wave. At a distance 1, you're standing 1 centimeter away from the source of wave, 2 centimeter away from the source of wave, 3 centimeter away, 4, 5, and 6 centimeter away from the source of wave. So the second one is the displacement distance graph, which can help you to find the distance. It can help you to find the wavelength, but the first one can help you to find the frequency. It can help you to find the time period. So let's check out the first question. Definition, I'm going to fast forward this. Displacement, the distance of a point on a wave from its mean position. Wavelength, the distance between consecutive in-phase points, or the distance between consecutive crusts, or the distance between the consecutive troughs. Okay, so use figure 5.1 and 5.2 to determine for the water wave the period t of vibration. So let's find the period t of vibration first. The second graph 5.2 is not going to help us because it's going to give the value of distance. In order to find the time period, you need to refer to the first one. So period is the time of one wave. So I'm going to highlight one wave, and we can just quickly see how much time does it take for one wave cycle to complete itself. And bingo, we can see it straightforward. It is 0.60. In 2SF, we can write it as 0.60 seconds. Up next, we have the wavelength. So for the wavelength, the first graph is not useful. Rather, I'll go with the second one. So from crust to crust, or from trough to trough, or the distance between any two consecutive in-phase points. Totally your choice. So for example, if I start off with the crust, then the next crust would be over here. Forget about the amplitude. The amplitude of this wave decreases as the distance increases. And this is exactly consistent with the formula that we studied, that amplitude of a wave is inversely proportional to distance. So if the distance is being increased as you move on the right side on the x-axis, you see distance from the source is being increased, then the amplitude of the wave would decrease. And that's why the graph looks something like this. Because as the distance increases, the amplitude decreases. This is exactly what we studied in the factors that affect the intensity. So if I take the distance between consecutive in-phase points, for example, from crust to crust, from 0 to 4, so the amplitude would be 4 with the unit of centimeters. So in 2SF, you can write it as 4.0 centimeters. So for speed equals to lambda over t, and lambda is 4.0 divided by 0.60. If you hit it on the calculator, 4 divided by 0.60 would be 6.666, so 6.7 centimeter per second. Use figure 5.1 and 5.2 to state and explain whether the wave is losing power as it moves away from the source. Okay, first we have to state. The state is yes, it does. And the reason being, I've explained it just a minute ago, that as the distance from the source increases, the amplitude of the wave decreases, and the lower the amplitude, the lesser the amplitude, the lesser the power. So I'm going to write the expressions. Amplitude is inversely proportional to this thing, and if the distance increases, amplitude would decrease, and less amplitude would correspond to less power. And this is the main question, the main event for today. Determine the ratio of the intensity of wave at source to intensity of wave 6 centimeter from source. Intensity of wave at source and intensity of wave 6 centimeter from source. So you need to find the ratio of the intensity. Let's call the first one I1 when you're standing at the source, and let's call the second one I2 when you stand 6 centimeter away from source. So which graph is going to be useful for us? 5.1 or 5.2? In this one, they have given you the information from the distance of the source. You see, 6 centimeter from the source. So the information is given about the distance. And the first one, when you're standing at the source. So you need to find the ratio of I1 over I2. And the very first formula that you have studied, I1 over I2 equals to A1 square over A2 square. You don't have to find the value of I1. You don't have to find the value of I2. You just have to find the ratio of it. The ratio needs to be found out. That doesn't mean you have to find the numeric value of I1 and the value of I2. No. So if we know the amplitude at the source, and if we know the amplitude 6 centimeter from the source, we can insert the values of A1 and A2, and we can find the ratio of I1 and I2. So what is the amplitude of the wave at the source? Let's check it out from the graph. So at the source means no distance away from the source. The distance would be 0. And what is the amplitude at that point? 2 millimeters. So A1 equals to 2 millimeters. See, the unit is millimeters, but the unit is not important here because the units would be cancelled out anyway. So the amplitude is 2. And what is the amplitude of the wave 6 centimeter away from source? So we have to be precise with it, and you'll just need to stretch a line from this distance all the way to the amplitude axis. So it would be some place over here. So it is exactly in the middle of 1.0 and 1.2 with the negative sign. So A2, the second amplitude, is first of all with the negative sign, and it's between the first and the second block, so it would be minus 1.1. If it were on this second line, it would have been minus 1.2, but it's exactly in the middle. So minus 1.1 millimeters A2 and 2 millimeters A1. So let us insert the values. A1 is 2 millimeters. Not going to write the units, but we have to take the square of it, divided by A2, which is minus 1.1, and square of it. The square is, you have to take square of the entire value, including the negative sign. Do not write it something like this. That'll be incorrect, because you have to take square of the entire value, minus 1.1. This is the amplitude. So we hit it on the calculator. 4 divided by, negative sign would be cancelled out with square anyway, but let me just write it down. Minus 1.1 square, and you get 3.3. Yes, 3.30. Into SF you can write it as 3.3. Second one you can do by yourself. This one, part B, you can do by yourself. Wavelength you can find by yourself. Phase difference I'll explain afterwards. Let's check out this one. Calculate the ratio of intensity of the wave Q to intensity of the wave P. Let's call the intensity of Q as I1, and let's call the intensity of P as I2. So the formula we have is I1 over I2 equals to A1 square divided by A2 square. This is the formula that we have. So what is the A1? It is the amplitude of the wave Q. Let's check it out. The wave q is, so this is wave q and the other one is wave p. Now what is the amplitude of the wave q? Either you can write with the positive sign or with the negative sign, doesn't make any difference. The amplitude of the wave q is 2 millimeters. So a1 equals 2 millimeters. Okay, yes, this one is 2 millimeters for the wave q, and for the wave p it is 3 millimeters. So a2 would be 3 millimeters. So 2 square divided by 3 square, it would be 4 divided by 9, and if you hit it on the calculator you get 0.44. And for the ratio we don't write any units. So you see, this is exactly the same. I hope you understand that this is the same formula. I1 over a1 square equals to I2 over a2 square. So you just if you bring I2 downstairs over here and you shift a1 square on the other side, so you get exactly the same. So this is exactly the same formula.